Good day, everyone. Today we will present our project title Telecommunication Switching System. This project focuses on designing and simulating a converged enterprise VoIP network using Cisco Packet Tracer. These are our team members. The first one is Dhanasilan, second is Hariharan, the third one is Navindraj, and the lastly is Nur Fatiha. We are moving to the introduction part. Nowadays, many organizations are replacing traditional PBX telephone systems with voice over IP, which is VoIP technology, to reduce cost and improve communication efficiency. This project focuses on designing and simulating a converged enterprise network for a four-floor office building using Cisco Packet Tracer. The purpose network integrates voice and data services into a single IP infrastructure through router on a stick architecture, VLAN segmentation, DHCP, and Cisco Call Manager Express, which is CME. By supporting these servers, we are used 16 servers, 8 PCs, and 8 IP phones to the system provides secure, scalable, and reliable communication while ensuring efficient network management and high quality VoIP service. Now we are moving to the project planning and timeline for this project. Okay, we have started our project from week 10 to week 14. There are few tasks we have scheduled for our teammates. From this slide, we can see that the project planning and timeline for completing the system development. The project was divided into several phases, including planning, network design, device configuration, testing, troubleshooting, documentation, and presentation preparation. With a proper planning, we have ensured that all tasks were completed efficiently and according to the schedule we have scheduled. Next, we are moving to the next slide. Okay, in this slide, I want to talk about the contributions of our team members. In this project, each team member was assigned specific responsibilities. Firstly, we can look to the Hariharan. His responsible is to configure for configuring the router, DHCP service, and Cisco CME while also assisting in troubleshooting. Also prepare for the presentation slide. Next, we are moving to the Dhanasilan. He was handled the network topology design, also VLAN configuration, switch setup, and technical documentation. He was assigned for that. The third one is Navin Raj. He is assisted with router configuration, network testing, and preparation for project documentation. Also, is assist for the presentation materials with Hariharan. Lastly is Nur Fatiha. She was focused on discussion, lessons learned, conclusion, recommendation, and future improvement for our project. That's all from me. Thank you.
Thank you, Hari. For the next slide is risk identification and mitigation. In this project, we identified both technical and logistical risks. Technical risks include network congestion, which may affect VoIP call quality, security threats to voice and data traffic, and compatibility issues between IP phones and networking devices. Logistical risks include delay in hardware procurement, challenges in user training and system adoption, as well as future scalability and continuous networking monitoring. Identifying this risk early helps improve project reliability and future maintenance. For the next slide, technical design. The technical design of the network uses a Cisco 2811 router as the core routing device and VoIP server. Cisco 2960 switches are used to provide VLAN segmentation across 4 floors to improve security and traffic management. Router on a stick configuration enable communication between VLANs. DHCP automatically assign IP addresses to connected device, while Cisco CME manages IP phone registration and extensions for VoIP communication. And for this slide, I will explain about the flowchart. The flowchart which shows the step-by-step process of deploying and configuring an IP telephony network using Cisco devices. The process begins with the start stage. First, we deploy the physical topology by installing one Cisco 2960 switch, two Cisco 2960 switches, Cisco IP phone, Cisco router, and connecting all the devices using the correct cables. Next is the wire infrastructure stage. Here the router is connected to the switches using gigabit Ethernet ports, and all PCs and IP phones are connected to the designated switch ports. After that, we configure the layer 2 switches. In this step, we enable trunking on the gigabit ports and create the required VLAN, which are VLAN 2, VLAN 3, VLAN 5 and VLAN 6. The next step is assigning VLAN tags. Access VLANs are assigned to PCs, while voice VLANs are assigned to IP phones. We then verify whether all devices have been assigned to the correct VLANs. If not, the process returns to the switch configuration until everything is correctly configured. Once the VLAN configuration is complete, we move on to the configuring inter-VLAN routing. This includes creating router interfaces for each VLAN and applying IEEE 802.1q and solution with the appropriate IP gateway address. The next stage is to configure Cisco Call Manager Express or CME. Here we enable telephony service, configure the maximum number of supported phones and assign extension number of IP phone. After the configuration, we check whether the IP phones receive the extension number successfully. If the phones fail to obtain the correct IP address or extensions, we return to the CME configuration and troubleshoot the settings. If the phone registers successfully, we proceed to the final stage. The last step is executing network verification. We test network connectivity by using ICMP ping between different VLANs and perform VoIP call tests between different IP phones extensions to ensure that both the network and voice communication are functioning correctly. Overall, this flowchart provides a systematic process starting from hardware installation, followed by network configuration, VLAN implementation, IP telephony setup, and finally testing to ensure the entire VoIP system operates successfully.
Now let's focus on the network topology of VoIP system of the company. We use one router and two switches. On the switch 1, we use for floor 1 and floor 2, and for the server room for database server and file server. For switch 2, we use for floor 3 and floor 4, and also the email, HTTP and firewall, and also the web and cache proxy servers. Moving to simulation and results. First, we focus on the data center and server IP verification. For database server, we are able to get IP address of 192.168.20.6, and for file server we got 192.168.20.7, both using the same default gateway, which is 192.168.20.1. For floor 1 endpoint verification, which is VLAN 2, our workgroup 1 is able to get the IP address from the router, which is 192.168.20.8, and for printer 1, we are able to get IP address of 192.168.20.9, and for the PC0 we get 192.168.20.5. All of these endpoints using the same default gateway, which is 192.168.20.1. Continuing on floor 1, for the PC1 we are able to get the IPv4 address of 192.168.20.10, and they use the same default gateway, which is 192.168.20.1. For floor 2 endpoint verification, which is VLAN 3, the workgroup 2 using the IP address of 192.168.30.5, and the printer 2 using the IPv4 address of 192.168.30.6. Both of these endpoints using the same default gateway also, which is 192.168.30.1. Still on floor 2, the standby server 1 get the IPv4 address from the router, which is 192.168.30.7, and PC2 get IP address of 192.168.30.2, and PC3 get IP address of 192.168.30.8. For the floor 3 endpoint verification, which is VLAN 5, our work group 3 using the IP address of 192.168.50.6, and printer 3 using the IPv4 address of 192.168.50.8, our PC4 using the IP 192.168.50.2. All of them using the same default gateway also as floor 3, which is 192.168.50.1. Continuing on floor 3, for the PC5, we still using the same default gateway, which is 192.168.50.1. The IP address of this PC5 is 192.168.50.5. For floor 4 endpoint verification, which is VLAN 6, be able to get IP address of 192.168.60.4. Its default gateway is 192.168.60.1. Continuing on floor 4, printer 4 able to get 192.168.60.5 as its IP address, and standby server 2 get IP address of 192.168.60.6, and for the PC6, we able to get IP address of 192.168.60.7. Finally, for our additional server room verification, the first email server got IPv4 address, which is 192.168.50.7. For the HTTP server, we got 192.168.50.9. For firewall server, we get IP address of 192.168.50.10. Lastly, for web and cache proxy server, we get IP address of 192.168.50.11. All of the servers got its same default gateway, which is 192.168.50.1. Lastly, we perform the ICMP data routing verification to test the end-to-end connectivity across our network. As shown in the command prompt outputs, we successfully ping the different floors, which is from floor 1 to floor 2, be able to achieve 0% packet loss. This confirms that our inter-VLAN routing and our trunking protocols are fully operational and stable. This simulation results confirm that every device in our architecture is successfully registered, correctly addressed, and capable of stable, high-speed communication.
Discussion. From the project implementation, we found that VLAN segmentation improves network security and reduce unnecessary broadcast traffic. Router on a stick enable efficient inter-VLAN communication, while DHCP simplify IP address management. Cisco CME also automate work deployment and simplify file management. Overall, the network architecture is scalable and suitable for features. In addition, implementing a dedicated voice VLAN improve call quality by prioritizing voice traffic. Automatic phone registration reduce configuration time, while structured IP addressing simplify troubleshooting and network management. The simulation results demonstrate reliable and stable network performance, making the design suitable for interpret information. In conclusion, this project successfully designed and simulate a coverage enterprise-wide network that supports efficient and secure communication. VLAN segmentation improves security, while automate IP allocation and phone registration simplify network management. The simulation verify reliable routing and stable web communication. Overall, the proposed network is scalable, cost-effective, and suitable for future organization growth.